Hi there, and welcome to the Echo Solar Home Tour. My name is Andrew Mills, and today we're going to be talking about a straw bale retrofit home in Drayton Valley, Alberta. With me today is Keith Warren, who's the homeowner and the builder of the home. Welcome to the Echo Solar Home Tour, Keith.
Thank you, Andrew. It's a pleasure.
Keith, your home is an example of a near net zero home that features exterior walls retrofit with straw bale insulation, 8.5 kilowatts of solar, and all electric operation. So, Keith, give me a bit of a background on why you chose to build your home like this. What were the main things you were trying to accomplish?
Well, Andrew, I've been working in construction and building since 1982, and I got started in the mid-70s in construction and became very interested in 1976 in the concept home that was done at the University of Saskatoon to kickstart the R2000 program. And I went out and took a look at that. And then I went down to California and I looked at some of the features that were being done at that time in terms of trom walls, in terms of water walls, heat sinks, etc. But it became very apparent to me that the real key to the pieces was a superior insulation envelope. And if that's what double wall is all about. The interior wall is your load-bearing structural piece, and the exterior wall is simply a cavity for insulation. So I started building homes under that pattern, and when I got about the time I got to 16 years ago, I started to look at how I can keep the insulation envelope at the same time, reduce the product I was using, because there's a significant amount of greenhouse gases that are involved in producing pieces like polystyrenes, fiberglass insulation, rock wool, etc., from the extraction of the raw materials to the production of it, transportation, etc. And in order to get our materials locally, I was looking at how I can utilize straw bales on the exterior of an existing building to do that super insulation job.
So, Keith, tell me a bit about the EnerGuide rating of your home. You say you got your EnerGuide rating done just yesterday. Do you have any historical data that suggests where the home might end up?
Yes, some of us still like to put the cart in front of the horse. So I built my first home with this idea and prototype 10 years ago. As one of the key factors is that you have to be able to keep that insulation dry, and I've worked out a process to do that. So after that home was in its 8th year, I was confident enough to try and build the show home, which was completed in 2018. That's this existing building. And the piece that's the straw is testing 100% dry. It's less than 12%, which is our ambient moisture in Alberta, and doing its job of keeping the building warm. So most people would have had the EnerGuide rating done initially. I didn't. I already knew how it would work from having lived in the other home for the previous 10 years. And at the first 2 years unoccupied, this home generated about 1,000 kilowatt hours of electricity, more than it used in keeping it heated. In October, we moved into this home, and now it looks like that we'll probably be in the neighborhood of 12 to 15 gigajoules of energy for heating, domestic hot water heating, refrigeration, all of those pieces that a home utilizes for its energy consumption.
So near net zero then. Okay. So now let's take a look at some of the details of your home. First of all, what would you say is the standout feature of the home?
Well, there's no doubt that the standout feature is the straw bale wrap. This is the home when we were just starting construction. We've literally gutted the interior. All the drywall was removed, all the insulation was removed, all the old electrical, All the old plumbing was removed, including in the basement floor and so on, so that we could rebuild this home. The structural part of these homes is very sound. This home is all fir construction, and it just needs to be brought up to 2020 code levels, and that's what we did. So you can see the roof line there. You can see the how it's extended. You can see how the windows come out, and the straw bales actually sit on that ledge there. So this is how we start with the construction. This is what's called a core-balled foundation. And so it's doweled into that ledge is doweled in by rebar into the existing foundation, so that it's just the same way you would do if you were going to put a heavy stone wall on the exterior of your building. The box there is the window well around the basement windows. In order to get a suite, you have to have big window wells, and you have to have egress.
So this is going to be filled with concrete then, this section?
With cement. You betcha.
Okay.
Yeah. And then in order to keep the straw dry, I had to figure out how to get air moving through the straw without using a mechanical device.
Okay.
And so on that ledge is sitting 8 by 4-inch cinder block on the outside, and then on the inside, right next to the foundation, is sitting 3 inches of polystyrene insulation, and between those two, that space is 3/4 inch washed rock. And the reason for that is those cinder blocks are bonded on the bottom edge, but not the vertical bonding, so air can move through them.
Okay.
The metal screen that you see there is to prevent friendly rodents from deciding to take advantage of an energy efficient home. And because metal and straw do not like each other because of condensation differences, I put 2 layers of fiberglass bug screen on top of the mesh to keep the straw protected, basically, and keep insects out.
Interesting.
You can see the roof overhang here. Now, what's happened is that if you look where the stucco ends, you'll see that's the original roof there. And by cutting the original eaves off and then changing the pitch of the roof from a 412 to 312, I'm able to gain 18 inches of vertical, and that allows me to put R60 fiberglass insulation throughout the roof. And it extended right out where that 2x4 is. That's where the outside of the straw will be when we're done. And that means that the insulation envelope then is right out to the outer edge of the straw.
So are you taking the old roof off completely, or just building over top of it?
Just building over top of it.
Interesting.
You certainly could do that. And then just replace the whole roof with trusses, but structurally.
So you're just going right over top of the shingles and leaving the whole thing there, or do you strip the shingles of the deck?
Strip the shingles, and you have to cut about 5 feet of sheeting off of the existing roof as well.
Oh, I see.
So that you
Okay.
get the area there, right?
That's interesting. Okay.
So now the roof is on, and this is what it looks like with the windows. And the windows actually are framed. Boxes are inserted in the old window hole, and then the window, I've set them in from the whole wall is 22 inches thick. These windows are set in at 16 inches on the inside, and then the outside is actually recessed 4 inches. And the reason for that is that instead of being right on the surface, one of the biggest issues that we contend with is wind effect on our surface skins. It doesn't matter whether you're wearing your clothes or you're a house. When the wind blows, you're losing heat significantly faster. And since windows by setting them back in that 4 inches, that creates an eddy, just like in a river where you have a rock, and now the wind can't get access to those window surfaces as readily.
Okay, so it improves the efficiency of the window slightly.
Exactly. It improves it. And part of my construction has always been, how do we take advantage of all these cumulative effects to make a more efficient home?
I've got a couple of comments about this picture. So first of all, on the upper right, I can see how the roof is coming out. The new roof line is coming. You can see the triangular section where the new
Yep.
roof line comes out with the old one. That's really interesting. The other thing you were telling me is that you are supporting these window boxes directly from the roof trusses. So they're actually being held from above rather than needing to cantilever out from the old window box. Tell me more about that.
Yeah, that's exactly correct. And so, in order to support the windows, because supporting structural pieces in straw has not had a great deal of success, and so I add an extra rafter truss on from the new on either side of my window openings, and now I can attach a 2x6 horizontally down the side, which then gives me the backing where the windows are, that where you see the Tyvek wrap is,
Right.
that's the behind that supports the window and support is attached to the box, and the window just sits right in there.
That's really interesting.
This is what it looks like with you can see the basement window well. You can see how I've formed a arch over the window, how the window sits inside the upper, and how the straw bales are put between. And well, we use 99% of all the insulation on the wall, excuse me, is straw. There's areas like right around the windows and so on that you need to use fiberglass and or styrofoam. And I think that's use whatever's the most efficient piece of it is the important call
Hmm.
here.
Hmm.
And then I put vertical strapping through, and the reason for that is that now I've got an area to attach the building paper to, with like a Tyvek style, and then you have to cover that with 2 layers of tar paper so that it doesn't get dirty, and will do its job. And now you can put your stucco mesh on and stucco.
So it's tough to see with the blue, but you can see the strapping vertically in the back, just behind the
That's
scaffolding there.
that's correct. So that's attached to that 2x4 at the very top on the roof line and all
Oh,
the way to
okay.
the bottom.
Interesting. And you said you got reclaimed wood for that, I hear.
Yeah, well, that's exactly the fences needed to be rebuilt on this property, and they were conveniently made out of 14-foot 1x6s and put on horizontally. So we just salvaged them and saved the shelving units inside the building, or all the old bifold doors, etc.,
Nice.
to try and help with that piece of recycling as well. And by doing this, the style of construction, the amount of waste that went into the landfill is negligible compared to what normally these would just be blown up and a new building put on the lot.
Yeah, right.
So this is the building ready for the stucco. We were waiting for stuccoers to get here and put the stucco wire on, and you can see how the windows are all recessed. The Tyvek is on, the tar paper is on, and we're ready to go.
That looks good.
This is some of the other features within the home. There's because it's all electrically driven. This house has a 200 amp electrical service to it, and we have a air-to-air heat exchanger that has services both the basement suite and the upstairs. So every room has exhaust on towards the ceiling, and I utilize the old ductwork from the forced air furnace that we took out to be our input for the main floor, and then added it for the rooms in the basement suite. So every room in the house has its own input and output for fresh air.
Hmm.
Every room has its own electric thermostat, controlled individually thermostat and baseboard heaters.
Okay.
The interesting piece with the heat exchanger, and I'm just going to go here, is because I used a slab on grade piece for my foundation to do the addition on, I also added 70 lineal feet of 4-inch light wall ABS plastic pipe so that I can draw the air from out for the air exchanger, the fresh air coming in from the outside of the building, but it flows through that pipe for 70 feet. By the time it gets to the air exchanger, even at -30, it's still coming in at +8.
So it's
So
still, it's pre-warming it then.
that's pre-warming the air. That's a huge increase in the efficiency of the air-to-air heat exchanger.
Interesting. Interesting.
So and in the hot water, domestic hot water, the electric tank this is where the cold water comes in. It's sitting in here. It's certainly if this basement room is not warm, if you had it around normal room temperature, 19 degrees, you probably would not have to turn it on. It would just store the water, and then the water moves from there so that every sink in the house, bathroom and kitchen, both of them, and the 3 bathrooms, this is the hot water heater on demand, electrically driven. So these little heaters have a 4,500 watt element, and the water, you can get it as hot as you want, as long as you want, but you don't have the problem that we do with centralized on-demand heaters where you're flowing a lot of water to get warm water to where you need it.
Yeah, I had that, and it didn't work out very well. I had to go back to a tank. That's very interesting, those little on-demand heaters.
Yes, they take up no space in the kitchen or sink cabinets, right? And
Interesting. So Keith, I see now this next picture, you're showing the depth of the windowsill. So this is a 16-inch deep windowsill. So that's where the straw is, and it's showing that you've got thickness to the walls. Tell me more about the finishing that you did here. Some interesting things you say you did.
yeah, I'm really concerned that we need to be looking at 100-year houses for our architecture, not 50-year houses. So I built all the wood in here is always rough maple,
Okay.
and cherry was we machined, milled, and then it's all the window wells are all finished. The woodwork, I used maple 3/4-inch plywood to build the boxes, and that way once the window was installed, we just had to varnish it, and we had a finished product rather than returning and so on.
Nice.
All the casings are solid maple, and cherry. It's varnished, and this wood will last for as long as it's kept dry. It will be here for an indefinite, literally an indefinite amount of time. So you can, if you're tired of the wood look, you can paint it, you can refinish it, whatever it takes, but
Right.
it will be part of this house forever. This is I'm a cabinet maker, so
Okay.
this is cabinets, and they're all in the same theme. They're cherry panels and solid maple frames throughout the house. And you see here that I didn't open it up to a completely open concept. You certainly could remove that load-bearing wall, and these older homes are almost ubiquitous to the way they were built. So I kept a beam structure and opened the wall up in order to give us more of an open look. And all of the window sizing, the windows are all triple glazed, double low E, argon filled. They were quite interesting when they were doing their smoke test and pressure test yesterday about the fact that they could not find any leakage around these windows.
Nice. That's a good looking space, Keith.
Thank you. And this is out the lot. The other thing that's so nice about in smaller communities like Drayton Valley, our standard lots in the 60s were 55 to 70 feet wide and 140 feet deep. So you have lots of room to be able to have garden space, to have storage. This garage I put on, the garage is also not straw bale walls. It's just 2x6 walls and R40 ceiling. And it's already has an electric car charger in it in place. And my power supply comes to the garage and then feeds the house from there.
Well, Keith, that's very interesting. Thanks very much for showing that to me today. Is there anyone you'd like to thank about building your home?
Yeah, I would really like to say thank you to all of the subcontractors that worked on this house, because it was a new program. It meant some re-education for plumbers and electricians, and we and I tried, and intentionally, everything in this home that I used for the construction phase of it is all available from your home hardware.
Interesting.
There's nothing in here that can't be sourced within 20 miles of Drayton Valley.
That's really interesting. Well, Keith, thanks very much for joining me today and showing me the pictures of your home. I'm definitely going to make the trip out to Drayton Valley on tour day to come and see this. This looks really interesting. I also want to thank our sponsors, our EcoSolar Home Tour sponsors. Our sponsors do offer many interesting services to help you build an energy efficient home, and we encourage everybody to visit them. Please visit our website to find more information on our sponsors. You can also find out more about the EcoSolar Home Tour, which is coming up this June. Our website is www.ecosolar.ca. We will see you on the tour. Thanks for watching our video, and thank you very much, Keith, for joining me today.